So what we're going to look at today, guys, is whether we can find the ratios used to convert from radians to degrees and from degrees to radians. Hopefully we can compare our circumference of a circle, which we know something about, and radians. Find the ratio of one full circle in radians. And connect the idea of radians to using basic fractions. What we start with is a circle, and we know certain things. We know that our circumference equals 2 pi r, and that there are 360 degrees in a circle. What we'll find is that 2 pi r, if we consider r to be the radian, is equal to 360 degrees. So you're probably asking, what is a radian? Well, when you draw the diameter of a circle and an additional radius such that the angle created, the central angle here, forms an arc length here that is equal to the length of the radius, so that we know that this is equal to this is equal to that. So a radian is an arc length that is equal to the length of the radius. And that ratio will be true for any circle. Okay? And the ratio of the number of radians it takes to go around our circle. So the green arrow represents 1 radian because the arc length is equal to the radius of the circle. How many radians does it take to go around a circle? Well, some of you may be making a guess at this based on this right here. But what we notice is that we have 1, 2, 3, 4, 5, 6, and then a little left over. And that little bit left over is 0.28 because it takes 2 times pi. So the rough estimation of pi is 3.14, and so if you double that, you get 6. 1, 2, 3, 4, 5, 6, 0.28. So 6.28, more accurately represented as 2 pi. So what we can conclude is that 360 degrees does indeed equal 2 pi radians. Now, if you take both sides of this equation and divide by 2, we can get a singular thing. So that pi radians, so that you're not multiplying by that 2, must equal 180 degrees. And really I should have the word radians put in here. Well, just to clarify, in case anybody forgot, what the significance of 180 degrees is that it is half of our circle. So to go halfway around the circle, you must have 3.14 radians. To go all the way around, you're going to need 2 pi radians. So from here on out, we'll say pi radians to go halfway, and 2 pi radians to go the entire way around the circle. Alright, so here's what we kind of figured out from the last slide. And what we want to look at is, well, how would I get either one of these equal to 1? Because you can take really any equation and kind of come up with a ratio. So for every 1 radian, how many degrees do I have? Or every 1 degree, how many radians do I have? And we're going to do that by either dividing both sides by 180 or divide both sides by pi radians. If I divide by both sides by pi radians, I would get 180 degrees over pi radians. And if I divide both sides by 180 degrees, I get pi radians over 180 degrees. Such that what I know is that to convert from radians to degrees, I want to multiply by 180 degrees over pi radians. Because let's say I had 2 radians, what I could do is 2 radians, the radians multiply by my top, by my numerator. The word radians, our units, actually cancel out, and we're left with only our degrees. So 2 radians would essentially become 360 over pi. To convert from degrees to radians, you're going to multiply by its reciprocal. So we multiplied by this to get from radians to degrees. Here we're going to multiply by what we found over here. So pi radians over 180 degrees to go from degrees to radians. And the same sort of thing holds true where, let's say I had 120 degrees. I would multiply it by pi radians over 180 degrees. And what we notice is, same thing here, my degrees will cancel out because this is really 120 degrees over 1. I'm left with 120 times pi over 180, and I still have my radians. So I have my radians here. Now this becomes something that we know with all our basic fractions. Okay? So fractions, we know we never want to leave something like this. So I'm going to do something like, get rid of my zeros, essentially dividing by 10. 12 over 18, that's an easy one to reduce. That is going to become 2 over 3. But you still have your pi, so 2 pi over 3 radians. And that's kind of how you convert. In the next video, we'll look at more examples on how to convert and some examples on some word problems, how to do it.